Today, we are going to discuss a very essential topic in information security systems, the software development life cycle. So, in this model, forms the backbone of all software development activities from the idea stage to maintenance. But at the end of this section, you will be clearly understand how SDLC ensure a structured, high quality, and efficient software development process. So, what exactly is the software development lifecycle? SDLC is a structured process for planning, creating, testing, deploying, and maintaining the software systems. It's like a roadmap that guides developers through each step of software creation, ensuring quality, consistency, and cost effectiveness. Its major goals are to reduce risk, obtaining time and resources, and it will align the projects with business goals. In short, SDLC ensures that every piece of software we build is systematic, efficient, and reliable. The SDLC is usually divided into seven major phases. First one is planning, feasibility analysis, system design, implementation, testing, deployment, and maintenance. Each of these phases has its own objectives, deliverable, and people involved. So if you skipped or rushing through one phases can affect the quality of the final product. The first phase is planning, which lays the foundation for the entire project. Here, project goals, requirement, and scopes are clearly defined. Stakeholders such as clients, managers, and developers who work together to finalize the timelines and resource allocation. In the activities which are include are market research, understanding customer needs, estimating time and budget. For example, if we are developing a university attendance management system, the planning phase would include identifying features like attendance tracking, report generation, and role based logging. A well planned phase avoids confusion and ensures smooth process throughout the STLs. Once we have a plan, we must check if the project is feasible technically and financially. This phase answers the question, can we really build this? Feasibility analysis includes technical feasibility, estimation, and risk analysis. In technical feasibility, do we have the right tools, technology, and expertise? It will tell that. In the cost estimate, is the project within the budget? In the risk analysis will tell you what could go wrong and how do we prepare for that. So if the project is found to be unviable, it's better to stop here than to waste resources later. A successful feasibility analysis prevents financial losses and helps in smarter decision making. After confirming feasibility, we move to system design. This is where we create the blueprint of the system, defining how the software will look and behave. The activities involved here is designing the system architecture, creating UI mockups, defining compatibility requirements. The output of this phase is a design specification document which act as a guide for developers in the next stage. For example, the design may specify that the database will use MySQL, the backend will be built in Java, and the frontend will be React. This phase ensures clarity and consistency before coding begins. Here comes the most active part, implementation. It is also called as development. In this phase, developers start writing code according to the design specifications. They follow proper coding standards, use version control systems like JIT, and perform regular code revise. For example, if our project involves multiple modules, student, faculty, and admin developers will code and integrated each part systematically. The key goal here is to convert design into a working product. Good implementation ensures the code is clean, efficient, and easy to maintain. Once coding is done, the next step is testing. Testing ensures the software meets the original requirements and works as expected. This phase identifies and fixes bugs, errors, and performance issues before deployment. Common testing type includes unit testing, which will testing the individual modules. Another one is integration testing. It will check if modules work together. System testing, evaluating the entire system. Automated testing, using tools to test faster and more accurately. Testing helps ensure that the software is reliable, secure, and user friendly. After successful testing, the software is ready for deployment. This means releasing the application to users either as a pilot version or a full launch. Deployment can be done on local servers, cloud platforms, or even mobile storages, depending on the project type. At this stage, it's crucial to ensure smooth installation, user access, and performance. Sometimes deployment happen in stages to gather feedback before the final release. The final phase is maintenance, which begins after deployment. Just because software is released does not mean the job is over. Maintenance involves fixing bugs that appear after launch, adding new features based on user feedback, updating security patches. This phase ensures that the software stays functional, secure, and up to date over time. For example, your mobile app often receives updates. That's the part of the maintenance process. Now that we understand the 7 phases, let's look at the different modules that define how these phases are executed. The 5 most common SDLC models are waterfall model, agile model, iterative model, V model, DevOps model. Each model has unique feature, advantages, and best use scenarios. The waterfall model is the oldest and simplest model. It follows a linear and sequential approach. Each phase must be completed before moving into the next. It's easy to manage and suitable for small projects with clear fixed requirements. However, it's not flexible. If you find an issue in a later stage, you can't easily go back to change earlier phases. Example, building a student's attendance system with fixed requirements. The agile model is quite different. It's iterative and flexible. Work is divided into short cycles called sprints, usually lasting 2 to 4 weeks. At the end of each sprint, a working version of the software is delivered, tested, and improved. Agile focus on collaboration, customer feedback, and adaptability. It's best for complex projects where requirements evolve over time. Tools like Scrum and Kanban support the agile process. In the iterative model, development happens in repeated cycle. After each iteration, the software is tested, feedback is gathered, and improvement are made. This allows early version to be delivered quickly while still refining the final product over time. It's great for progression development but can lead to technical debt if iterations are not managed properly. The V model is also called the verification and validation model. Here, each development phase has a corresponding testing phase. This ensures early detection of defects and higher product quality. It's ideal for time constraints or safety critical projects such as healthcare or aviation system. However, it's not suitable for projects that require frequent changes. The DevOps model integrates development and operations. It promotes automation, collaboration, and fast delivery using CI CD pipelines, continuous integration, and continuous deployment. DevOps ensures that every code changes is automatically tested and deployed. This results in faster updates, fewer bugs, and continuous improvement. Although it has a high setup cost, it's excellent for large organizations with multiple teams. The SDLC framework brings several benefits: structured and organized workflow, better project management, consistent software quality, early risk detection and mitigation, controlled cost and timeline. In short, SDLC ensures that projects are delivered on time, within budget, and with high quality. Every SDLC process involves risk. Common risk includes technical risk, tool, incompatibility, scalability issues. Financial risk are budget overruns. Scheduling risk are project delays. And security risk are data breaches vulnerabilities. To mitigate these, organizations use DevSecOps, which integrates security practices into every SDLC phases. In real-world projects, we often use frameworks to manage SDLC efficiently. First one, Scrum, which works with Agile, divides work into sprints using rules and backlogs. Kanban focus on continuous workflow visualization, great for ongoing tasks. Traditional tools like Gantt charts and critical path method work well for waterfall projects. These tools help teams monitor progress, spot bottlenecks, and maintain smooth communication. Jira is a popular tool that supports both Scrum and Kanban workflows. It allows automation, task tracking, and collaboration among developers, testers, and managers. Jira also integrates with tools like Slack and Confluence, improving productivity and transparency. So, in many software companies, use Jira to plan, execute, and monitor every phase of SDLC efficiently. To conclude, the software development lifecycle gives structure, control, and quality to software projects. It helps teams manage complexity, reduce risk, and deliver reliable solutions. By choosing the right model, whether it's waterfall, agile, or DevOps, organizations can achieve their goals more effectively. And thank you for your attention. I hope this session helped you understand how SDLC provides a systematic pathway from idea to deployment. Thank you.